Good evening, everyone. My name is Riya Sharma. I am a student from IIT Kanpur. I have recently received PMRF fellowship. I'm a third year PhD student. I did my BTech from NIT Nagpur, and then after directly I joined my PhD program. I am a course TA as well as the PMRF TA of thermodynamics of fluid phase equilibria. So here we are in the week two. I have a I hope you have cleared week two assignment by now. And week one I have also uploaded on the YouTube channel, which the link, everything has been given. My notes has also been given, though I was out of town at that point of time, so that's why I was not able to give you hand the online lectures which we generally are provided to give. But okay, from this time I have started. Last time it was handwritten notes, but it was a bit easier, you can say, into a hands-on session on classical thermodynamics. Now we will do a rigorous exercise of thermodynamics of fluid phase equilibria, the actual starting of thermodynamics of fluid phase equilibria. I will start by taking your assignment questions also. There are my questions also, so we can go, if that time permits, we can go for 2 hours of 20 questions or so. Howsoever, I will try to cover assignment questions initially, then I will bring some one or two more questions of my own, and that way I will be able to do it. So that's why I have taken the first question of your assignment, and which we will be trying to do, and which we will try to solve it. I will wait for 2 minutes, because since it's a starting only, let everyone should join the class. So I will wait for 2 minutes. By that time you can start solving the first question. Okay, so I will start my lecture by 6:05. Let everyone join, whosoever gets settled up, and then we will join, then we will start the lecture. But as you know this question, you know this, so you can just re-revise it. It is: liquid water enters an adiabatic piping system at 10 degrees Celsius at a rate of 4 kg per second. If the water temperature rises by 1 degree during flow due to friction, the rate of entropy generation in the pipe is, there are four options: 21, 29 watt per Kelvin, 39 watt per Kelvin, 49 watt per Kelvin, and 59 watt per Kelvin. So you start doing that, and by the time let's wait for people to join it. Okay, so I guess it's been almost 4 minutes now. I will wait for one minute more to let anybody else also join. I'm checking on the video lectures of mine also if there are any questions, and there are no questions as such. Okay. Okay, so shall we start? It's almost 5 minutes, 10 seconds to 5 minutes. And that this is a easier question actually. I really like the all 10 questions. It has given you conceptual things about your refrigerant, COPs, then liquid water data as well. So let's start it. Okay, so let's start it. So first question says like liquid water enters, so it enters at an adiabatic piping system at 10 degrees Celsius at a rate of 4 kg per second. If the water temperature rises by 1 degree Celsius during the flow due to friction, the rate of entropy generation in the pipe is the four options. So always I prefer whether to given a question you don't know how to strike a concept, you should always write what is given to you. And it should also liquid water, it has says, so you should entering temperature you can take to 78 or 283 Kelvin as well. Okay, so I will take TCS to 83 Kelvin, and we should, what liquid water we know, so we should know. So almost given scenario is saying given CP is equals to 4.18 kilojoule per kg into Kelvin, right? The second thing it has given is m dot. M dot is equals to 4 kg per second, and it is saying that TC, what I was saying, the okay, this has gone a bit, my apologies. Yeah, so it has given the values of TC is approximately yeah, so TC value is approximately given as how much? TC is almost 283 Kelvin, I was telling you, and TH is equals to 284 Kelvin, because it was given that 1 degree Celsius, so delta T which has been given what for you is 1 degree Celsius, so TH, the heating output, will become as 284 Kelvin. So a small hint I will like to give you, that S dot gen, because entropy generation they are asking, so it's a very easy question. I should write the formula in a different color because that's a good point generally, so I'll write with red color. So S dot generation will be equals to m dot Cp ln of T, it is Th by Tc. Okay, so I think so there's some network issue which is getting, so I am trying to keep my video off for a while because there's a network electricity issue. Now you can get it. Yeah, so it has been saying it is S dot gen is equals to Th by Tc. So going by that phenomena, I'll take it. You just have to apply this thing. S dot gen is equals to, you have all these value, you just have to put m dot as 4 kg per second, Cp as 4.18 kilojoule per kg, and you have Th as 284 Kelvin and Tc as 283 Kelvin. Okay, so we'll go by that. Yeah, I'm sorry for this. So yeah, I'll go by that formula. So it will be how much? You just have to change it. If it is kilojoule per kg, so Cp is in, we want in gram because it is like kg you want, so that should be, so you can take it as joule per kg. So take Cp almost equals to like Cp is almost equals to 4.18 kilojoule per kg. So just change kilojoule to joule. So Cp will become 4180 joule per kg into Kelvin. Okay, so this was Kelvin here. So this is a small rough work which I am trying to do. So we will have 4 kg per second. So 4 into 4180 into ln of 284 by 283. So use your calculator to get the answer. The answer will approximately be, because I have solved this earlier, it will approximately be around watt per Kelvin. B. So I'll just write the answers in a good way. So answer will be equals to 59 watt per Kelvin. This is your first answer. Please revise it. Try to analyze how it is, how we have done that, and we are good to go with our another question then. That is, you have to write that question. So what we have done in this question, I'll just remove this. Yeah, so what we have done in this question is, we had liquid water enters at an adiabatic, so we had all the information, we have rewritten it. Cp we have done, delta T we have given. We just use the formula Sgen is equals to mcp ln th by tc. We just applied that formula, and here is the answer. Any doubt, anything we can do? And let me check if somebody has entered. No, nobody has entered till now, so I'll just remove this. Yeah, the second question I want, because that's my own question, so I want you to write it simultaneously. We will write it, so it's better, because that is a better way to go ahead with our topics. So that's how I want you to write. So I have my questions with me. So yeah, so let's start the question number 2. So question number 2 is, I wanted a pen. Let's take a pen and I'll start writing. So this has been done. Let's go to question number 2. Question number 2 says, let's start with me writing. A heat pump is absorbing heat from the cold outdoors at 5 degrees Celsius and supplying heat to a house at 25 degrees Celsius at a rate of 18,000 kilojoule per hour if the power consumed by the heat pump is 1.9 kilowatt. The coefficient of performance of heat pump is. So let's start our writing information, like what it is. what it has been given to us, that a heat pump is absorbing heat from the cold outdoors at 5 degrees Celsius and supplying heat to a house at 25 degrees. So it is supplying heat to at 25 degrees Celsius at a rate of 1800 kilojoule per hour. If the power consumed by the heat pump is 1.9 kilowatt, the coefficient of performance of heat pump is. If you want option, I'll just write it's not there. Okay, fine. So A is 1.3, B is, let's say, 2.6, C is approximately 3, and D is 3.3. Okay, so let's start the questions. So as I told you, you'd have to write the answers. So this is answer 2. So what has been given to us? Tc equals to 5 degrees Celsius is approximately 278 Kelvin. TH is equals to 25 degrees Celsius is equals to 298 Kelvin. For us, it is given that heat is equals to 18,000 joule per Kelvin, which will be equal to, it is kilojoule per Kelvin, right? Let me check once again. It is given 18,000 kilojoule per Kelvin. So my mistake here. So so this is 18,000 kilojoule per Kelvin. So if you want, is it kilojoule? How is it possible? Okay. So that is not kilojoule per Kelvin. Here it is a mistake. So here it is kilojoule per hour. So if you want to change, so here's a good point. If you want to change R to, so basically you want to change R to, so one significant point is you have to change R to second, or you can say kilojoule per hour to kilojoule per second. That is a way of. So what you have to do, you have to do 18,000 as it is kilojoule, and I want second, so you have to multiply it by 16 to 60. Okay, so that value will approximately, you should start it, yeah, it will be 5 kilojoule per second. Then what is given to us? So we have used 5 degrees Celsius, 25 degrees Celsius and 18,000 kilojoule per hour. If power consumed by the heat pump is 1.9 kilowatt per hour, so W which has been given, the power to us is W in, which is equals to 1.9 kilowatt, and they are asking what is the COP. So when you write all these things, the crux is that only, that when you start writing all these things, the easiest concept which we will be coming up to is like everything is given. Now you have to apply COP of heat pump. What is COP of heat pump? It says, and what has been given to you, and what is the power consumed you have given. The power consumed, and it has been given the QH value, the heat in, or the rate of, at a rate of 18,000. So heat supplied and power in, consumed you have been given. And if you go by that logic, it is so easy that nothing has to be done. The information is extra when you have, what is COP of heat pump? It is heat divided by power consumed. How much was that? So heat in was always given to us as 5 QH. QH by WA. So do you think the TH and TC value was needed? No. It was a simpler one, that 5 divided by 1.9. How much 1.9 kilowatt is? It is actually the same as 1.9 kilojoule per second. Because what is, if you see this, what is basically joule per second. So it will be approximately 5 by 1.9, which is equals to 2.63, and we have few answers which will be approximately equals to 2.6. So our answer here becomes, if you'll see, your answer will become 2.6. B option. Am I correct? So as you write the questions, everything is super easy to solve it. That's what my experience also says. So it was given that a heat pump is absorbing heat from, so let's revise that for once. It was absorbing heat from the cold outdoors at 5 degrees Celsius, and then it was supplying heat to 25 degrees Celsius. The heat in was given that at a rate of that supplying heat has been given at it, if power consumed. So we know that heat supplied by power in is COP, so we don't even, these things were just a buffer. It's a buffer. There's nothing, no use of it. Okay. Now let's take one of your assignment question now. So let's take one of your assignment question. I think so. I'll take the assignment question only. So let me see where is my files I have. So I'll copy that part. No, I have some problems. Just a second for a while. Okay, so that's your assignment question. I have not here. I have your assignment question number 2. So if I'll go by that, it says a heat pump absorbing heat from the cold outdoors by this values heat pump. So will you able to do? So it was like that only. So it says, so this was my problem which I gave you. So question number 2 of your assignment says, so I won't do that question. I would just want a hint from your side. So question number 3 is assignment 2 problem. Question 2. What does it say? A heat pump is absorbing heat from cold outdoors at 10 degrees Celsius. So here TC will approximately become 10 degrees Celsius, and it goes outdoors, so TH will become how much? 30 degrees Celsius. It is saying heat is at the rate of 36,000 kilojoule per hour. So their QH is equals to 36,000 kilojoule per hour. If the power consumed by the heat pump is 5 kilowatt, so same thing, that work input is given as 5 kilowatt. Can you find the coefficient of performance? Exactly similar question I tried to take it, so I won't count that as question number what do you say, I won't count this as your, so this is my hint which has been given to you for your assignment 2, question number 2. So I took first question from your assignment and the second question is this one. I hope you can get it. So let's start with question number 3 of mine. It is easy. Some things have been given in buffer. So you have to write the question with me, because if I'll start doing with myself and putting the question, it won't give you that nice impact also, I feel. So let's do it. Then I'll take exactly the same question from your assignment and try to relate by that. So question number 3 of mine. So it is saying 2 Carnot heat engines are operating in series such that the heat sink of the first engine serves as the heat source of the second one. If the source temperature of the first engine is 1300 Kelvin and the sink temperature of the second engine is 300 Kelvin and the thermal efficiency of both engines are same the temperature of the intermediate reservoir. The temperature of the intermediate reservoir is. Okay, so this is our question which we got, that 2 Carnot heat engines are operating in series such that heat operating or operating in series such that the heat sink of the first engine serves as the heat source of the second one. If the source temperature of the first engine is 1300 Kelvin and the sink temperature of the second engine is 300 Kelvin, of the first engine serves as the heater. So it's like in a series. See if you'll understand. The system is in a series operation which is given to you, and that has been our input. So if you'll think about it in that sense, so how we are doing it, you try to visualize it. I'm trying to make it that heat in engine 1, it is the source, and there is another, I'll say middle one if you want, and we will go by that. It will take the heat. It is heat engine 2, and this is the T. So there is it. So what we have been given to us, if you'll write all the given information, TH is 1300, TL is 300 Kelvin. The thermal efficiency of both engines are equal, right? This has been given to us. If you'll see, of the thermal efficiencies of both engines are same. So we have been given this thing. So what is the formula? Basic thing is, we know that thermal efficiency, how much it will be for the first one, T mid by TH, and you just have to equate this part. So how much this will be? T mid by 1300, and this will be equals to 1 upon 300 by T mid. And we got, if you'll try to manipulate this part, this thing will cancel by this will cancel by this. So this will be equals to T mid by 1300 is equals to 300 by T mid. So take this here, and how much you got? T mid whole square will be equals to 1300 into 300, and T mid will approximately be equals to 625 Kelvin. This would be your answer. Did you get that? So this is the answer which we got. You want me to revise it? I'll revise this thing. 2 Carnot heat engines are operating in series. So there is one heat engine. So this is my first heat engine. This is my second heat engine. Such that the heat sink of first, this is the first engine, is the source for another. So this is basically the sink for one, is source for the second. That is what it was saying. And the thermal efficiencies. So this is actually a very important point. So I'll highlight this formula. The thermal efficiency formula, you should remember that it was 1 by T mid by TH, or it was 1 by TH by TC. So we just put that to this formula and we just equated it according to our thing. So this description is important. If you understood this picture, you are ready to go anywhere, wherever you want to. Okay, so here it is what it was for us. Okay, so are we good to go with everything now? I hope yes. So yeah, now let's do another question. Let's go and write the question, or I can just copy paste it. I should have copy pasted the before one as well. So this is also similar to your assignment problem. So I hope you can do assignment problems now very well. So if I'll take this as a question, because rather than writing all these things, I'll copy paste this thing. Okay, so I am copy pasting it. Because there's some issues happening with it. Why do you can just see this question for a while. Which of the following second law statement is correct? The entropy of an isolated system must remain constant or increase. The entropy of a hot copper block decreases as it cools. If ice is melted in water is an insulated container, the net entropy decreases. Work must be input if energy is transferred from a cold body to a hot body. So try to see this question, and by that time I'm trying to put this into, I think so some issue is happening. So this is your homework question which you can do. So rather than that, it is similar to your question number 4 of your assignment, I guess so. So that question I'll try to, rather than writing it out, I will give you an example about it. But right now let's do another question where I will write it. It's better I'll write it because there's some issues happening in copying it. So let's take this one, liquid water. Yeah, this is a very good question which I always like. So you can tell me this question. So your question number 5 has now been solved. So let's go to another question now. This is your question number 9, I guess so. Let me see if I can. If I can take your assignment problems. Yeah, so here it is. So taking your question, like if mercury were heated So this is a good question. Let's take this. If mercury were heated from 0 degrees Celsius to 1 degree Celsius in a constant volume system, the pressure developed in bar would be, so, and the values which has been given to you, given kT is equals to 5.32 into 10 raised to power minus 6, and alpha at 0 degrees Celsius is equals to 18 into 10 raised to power minus 5 degrees Celsius inverse. Your options I should also give you: 43.2, B is 53.8, C is 33.8, and D is 26.4. So if mercury were heated from 0 degrees Celsius to 1 degree Celsius in a constant volume system, the pressure developed in bar would be, and it is saying that this has been given, the kT values has been given, and your alpha value at 0 degrees Celsius has been given. It's a direct implication of formulas. It's basically you just have to apply few formula, and you'll be there to go ahead with the formulas. Okay. So yeah. Can I further try to check that the question is correct? If mercury were heated from 0 degrees Celsius to 1 degree Celsius at a constant volume, okay, and the pressure given developed in bar would be given kT. Yeah, so let's try to solve this. I'll give you a few minutes to solve it by yourself, and then we will do it. Okay. So I hope you are able to do, because that's a very good question actually. So let's do it. So basically we need to find how much del P by del T at constant volume, and by product rule we know del P by del T at constant volume is equals to minus del V by del T at constant pressure into del P by del V at constant temperature. Also, we know that alpha P will equals to del V by del T at constant pressure, and kT is equals to 1 by del V by del P at constant temperature. Therefore, if you know all these things, this thing will come across alpha P by kT. If you will divide this by this thing, they both will get cancelled out, and so I won't be telling you like do exactly the similar thing, but this has a direct implication. If we'll see what is the alpha P value and by kT value, and now we've tried to integrating it, but what we have to think, because we have been given these two values as a constant value. So what we can think about it, we can just, I'll write this out. integrating and assuming alpha p and kt to be constant, delta p is equals to alpha p by kt into delta t, which is equals to 1.8 into 10 raised to power minus 5 divided by 5.32 into 10 raised to power minus 6 into 1 degree Celsius, which is, now you can just try this out by yourself, that how much will the value will come, and then we can go ahead. I hope this much is clear to you. Yeah, so you have already been given 1.8 into 10 raised to power minus 5 and 5.32 into 10 raised to power minus 6 value already of alpha and kt. So you can just write here given values as kt equals to 5.32 into 10 raised to power minus 6 and alpha at that temperature is equals to 18 into 10 raised to power minus 5 degrees Celsius. And one more thing which you have been given is 0 to 2. So 0 to 1, that delta T is also equals to 1 degree Celsius. So you just have to put all these values into this form. And it will be this will approximately be coming around, which we can say 33.8 bar. And what is the option? This is the answer. This is option C. So basically delta P is equals to 33.8. Just keep that in mind. I hope you are good to go with it. You can revise this question once again. You can see where it is. By that time I can go and write the next question. So I should write the question number 5. For a gas, its behavior can be Okay, so I hope you revise this question once again, and I'll give you an idea for a while. So it was like if mercury preheated from 0 to so delta T was already given to us. Delta T was given to us. We have been given alpha value and KT value. The important part was that we should know what is the alpha P value and KT value, and we should know a basic manipulation of product rule. When we will try to see alpha B by KT, we just want to integrate this part. And when we will integrate, we have all the values. We have delta T values, alpha P values, KT values, and we are good to go with this. So this is 33.38 Kelvin, and your option correct is the C1. I hope you are now able to do question number 9 of your assignment 9. So if I'll say similar to assignment 9, assignment question 9. Okay, that we can go ahead. Now a similar question to your similar question to question number 10 of your assignment. Let's try to do that. Okay, so what we are given: for a gas whose behavior can be described by PV by N minus B is equals to RT, and del S by del V and del S by del T would be respectively B. So what we need to find out that at constant temperature, how much is del S by del V and how much is del S by del P. So I hope you got. So here is a basic concept of Maxwell relationship we have to use. So we have to use Maxwell relationship. When these type of questions come, just try to remember a very important rule, which I also always say, it is Maxwell relationship. So using Maxwell relationship, and what we have, so already just, so first you write what is given to you. PV N minus B is equals to RT, and what we have to find out now, we will do apply the Maxwell relationship. So how much this value will be? Del S by del V and del P by del T at constant V. So because we know that will be del P by del T, we should know how much it will be NR. Just try to calculate this thing. So how will be, just differentiate this. P by T is equals to F by V, right? Are we online? Okay, so this is V by N. So given for you is what is given to you is this. with this thing we have to given, or we have been given this value. So we have been given this value. How can we do? Can I take n as the denominator and r into t as this? I want p by t because we want del p by del t at constant value, right? So how much that will be? nRv minus nb. Will that be a constant value or not? Del p by b and r by v minus nb. So please recheck this. So with this thing we already got. How much this value is? Let me write the answer. This value is what they were asking, del S by del V at constant temperature. So here is your answer for a small part. Now I want to calculate another thing. So using Maxwell relationship again. Del S by del P by del T will be equal to minus del V by del T at constant pressure will equals to be how much? Now we have to see. So we have to find out V by T. What we have already? We want V by T. So we have already PV by N, or you can say you have this nRT, PV minus PV minus NB. You have nRT already. So you want something like V and T. So if I'll take this P on another side, because nRT by P, you have already V minus NB. So you just have to take T to that side. So you want basically V by T minus T by P. So you just basically want del V by del T at constant value. So this will be equals to nR by P. But there is a negative sign, so you just only have to put a negative sign. How much that will be equals to? This will be equals to del S by del P at constant temperature. Are we good to go with that? We have a value already to us. What we did, whatever we have been given, we just try to balance it out, find it out the values. That PVL nRT by V has already been given to us. So we just try to do few things and just differentiate it. You got the value. Cool. Are we good to go? Are we good to go? Yeah. So let's write another question now. How much that will be? Question 5. We have already done 5 questions. Already we are good to go with 5 questions. So now I want another question which I have made. So let's think about if you want to do, yeah, this is similar to your assignment 8 problem. So let me write it. For a gas, this is question number 6, I guess. So this is question number 6. Okay. So I'll try to write it under it only. Okay, so where it was question number 5, I'll write it here. Okay. Yeah. So here is question number 6. What is question number 6? For a gas whose equation of state is P, B minus B is equals to RT. So it is asking the heat difference Cp minus Cv is how much? Isn't it the similar question to your? I think it is a better one because this is a bit, yeah. So what we know already is that Cp minus Cv is equals to Tv alpha square by Kt, right? Now what do you want? Alpha is equals to 1 by V. Just try to find out these things. Del T at P and constant Ni, right? So here Kt will be equals to minus 1 by V dV by del P T comma Ni. So Cp minus Cv will also equals to T into V minus V square del V by del T plus square into P into V into del P by del V into T. So if we can see these two, we can cancel out this V square. So we are left with equals to minus T del V by del T square P into del P by del V into T. So it's a basic numerical which we are solving. So also we know for the given gas, P into V minus V equals to RT. V is equals to RT by P plus V, which is equals to del V by del T at a constant pressure, which is equals to R by P, right? So if I will go ahead with this, P equals to RT V minus V, which is equals to del P by del V at a constant temperature is equals to minus RT to V minus B whole square, and taking this ahead, minus P into V minus P. Right? Am I on track? So what you need to do, you have to now substitute Cp minus Cv is equals to minus 3 R by P whole square into minus P into V minus B is equals to T R square upon P into V minus B is equals to R. Therefore, Cp minus Cv is equals to R. And this is a forever formula which we should always remember, that Cp minus Cv is equals to R. Always remember this. This is a very beautiful formula. I feel that everyone should remember that. It can always be asked, it has always been asked in GATE also, that how much this value is. So just remember that. So I hope you are now good to go. You can just look at it for 5 minutes. I am keeping it here, and you can look how much is the value. I'm giving you 4-5 minutes so that you can check this thing. It's a beautiful question. Now I can on this thing. You can take 5 minutes of time to see that. Have you got that? Cp minus Cv is equals to Tv alpha square by RT. We just have to substitute all these values and you will be going. It looks like it is a very huge formula, but it is not. It is like a very easy intimidated where you can show that it is the one. So yeah, I'll broader this thing if you want, but yeah, let me see if somebody has joined. Nobody has joined. Okay, so yeah, this is we have. I'll give you 2 more minutes to think about it and we are good to go. I hope now you have got the clarity. I will now shift to another problem, which will be this. I can take this one also, like the kind of relatively be a minus y cube del x by y del y can be expressed as the following. So I don't believe in giving what you say the options as such. You should solve properly, then we can think about it, but we should always solve all these questions very properly. So that's what we have been given. So minus y cube del x by y. Let me write this question. So this is our question number 6. This is question number 7. Then we will take another questions if we having time, but yeah, I don't want to create this hectic wala thing. So this is minus y cube, how much, del x by y del y. Right, this one, let me see, at constant w, right? And this is at constant w. So that is saying can be expressed as which of the following. So taking this part ahead, you can think for 2 minutes and then we will start solving it. Okay, this is similar to your question number 7 only, right? So I'll keep a bit similar question, but different one. I wanted to give you, like, since your 7th question was a bit easier, so this was your assignment number 2 of it. So I can just 2000, rather than taking 2020, yeah, rather than taking assignment 2, I should, so this was your question, so I'll just change a bit my question. So can I take this as minus y square, because if I'll just solve everything of your, then it is like you won't be trying much. So I'll just shift it, and can we just take black pen? Yeah, can I take this one? Yeah, this is much better, because then you won't be using this as a, like, oh, I got the final answer, and you won't be doing that. So I am taking this as minus, so I'll erase this, so minus, so I'll keep this as minus y square. Are we good to go? Because then I will try to answer that. people can start trying by themselves so that you can get the answers. But it's a very easy question. You just have to use the dividend rule. So I'll start by so just follow my step. I hope everyone is getting where we are right now. So this is given minus y square del y by x by w. So I just put it minus y square and I just took it inside. So x by y by at constant w, and then I take it as 1 by y as outside del x by del y at constant w. So this part and this part. Okay. So here this one, and this one we have taken, right? So minus y square x by y square plus 1 by y del x by del y at w. So which will be equals to x minus y del x by del y. You just have to multiply and you are there. Okay. Isn't it easy? It is like qualitatively very easy question. You just have to apply few things and you are good to go. So this is the answer. Just check that for 5 minutes, like how we have done. It's just basic concept of using the product as well as, what do you say, the partial differentiation, keeping one constant and the other part as constant, and then we will go ahead with it. So it's like a basic geography and you are about to give that. I hope you are good to go with it. If some other question you want, so I'll be uploading these lectures as well. I'll be uploading these lectures as well. Somebody has some issue, they can constantly tell me that this is the problem they have got. I'll re-revise it. Last time I asked in the lecture about one or two problems, like doing the steam table, doing things. So you can take some time to make sure that you got the problem. Okay. So I am writing the question. By that time you can go ahead with the question solving part. I want you to be a bit more sure about everything now. Okay. Okay, so I'll choose this one and I'll take this. Okay, yeah. So let's see question number 8, which is similar to your assignment number 6 question. Yes. So there is this question. Now view the chemical potential. So I'll give you a question and there are options as del S by del Ni, U, V, and Ni. B is del S by del Ni at constant internal energy, volume, and particle N. The third is minus P del V by del Ni, U, V, and Ni. And question number D, P del V by del Ni, U, V, and Ni. Okay, so read this question carefully. You just have to apply first law and then some relationship of your first law, the whole first law, where you have to take every part of it, like what is my first law, like U dV plus T ds, everything you have to take, and where number of molecules is the concept. Okay, so I'll start solving it, you solve yours, and then we'll try to see. Okay, so from the first law, du is equals to Tds minus Pdv plus sigma of I equals to 1 to n. So this first law I was talking about. So keeping u, v, and nj, j not equals to I fixed, we get, so this part du will become 0 because keeping u and fixed, so this is constant, so du will be constant, so this will be equals to 0. This is Tds. Then it is saying dv also constant, so this part will become 0 plus j, and j is also equals to fixed, so only one picture will come, d and I. Why it is so? Keep this as, because we keep the nj value also fixed, and j not equals to I, right? Fixed. This is because of that. So will you now get mu I is equals to minus t? Just take this here. ds by del ni, keeping what all things we kept constant? U, V and Ni. So which option do you think it matches? Minus T. So this will be option. Right? Think about it. Solve patiently. So answer is equals to B. Mu I is equals to minus T del S by del NSI U V and N. This is your answer. I hope you got this. Take 2-3 minutes to to digest this problem, to see what we have applied, how first law has been applied to it. D equals to TDS minus PDV and mu I dni, and keeping U, V and Ng as constant, we are about to go in. Okay. And then there was some basic problems which I saw, like kind of these match the following. I don't know why it is. So I gave you to read this problem. So here you can think which of the following second law statement is incorrect. So and there is one more question which is the match the following type, because I have given everything. So yeah, sixth question we have solved, eighth we have solved, ninth CP minus CV values we have checked, and the rest we are good to go. So let me see if there's another thing left. The fifth question we have already solved because it was liquid water which was having adiabatic pressure. And if you want to solve the match the following question, it's there in your, so if you'll see your own, so if you want to see your assignment problem, so your assignment problem has this question where it was which of the following statement is true in any process. Entropy is always conserved. Coefficient of performance of a refrigerator and heat pump are different. Kelvin, Planck and Clausius statement are not equivalent. Efficiencies of Carnot reversible and irreversible heat engines are equal. So in this assignment question, let me write, I'll give you a hint for it. So this is hint question assignment. I should choose a black color. Hint question number 9 I can put. This is question number 9. I can put question number 9. This I'll take as hint also. No, it should not be a hint. It should be assignment question number 4. Which of the following are true or not? Assignment question number 4. So they are asking which of the following are true. So in any process, entropy is always conserved? No. For a process to be continuous and think it should, so A part where it is saying in any process entropy is conserved? No, energy is conserved. Is conserved? No. This is wrong because we should know that always here energy is conserved. Entropy for a process to happen, for a spontaneous process, entropy always increases. Since here entropy increases. Right? Now second part, let's see this one. The B part was coefficient of performance. So we'll just write as COP of refrigerator and heat pump are different. Just remember the formulas. So this is true. Let's take the C option. Kelvin, Planck and Cloutier statement are not equivalent. It is same. It is second law of thermodynamics. If you think about it, it is basically the second law of thermodynamics where they say the same thing. So their statements are different, but they are equal. Okay, so this is wrong. And what is the D statement? Keeping it alive. Efficiency of irreversible are equal? No. Eta of Carnot reversible and irreversible, it has been covered in your lectures, are equal? No, they are not equal. So that has been covered. So only one thing we got, that COP of, they are different because the units are TH by TL, or there is one way TL by TH. COP of refrigerators are greater in general. So if you think about this, you are saying it. So it was saying the question I should also write which of the statement are true. So now you can do all your questions, I guess so. The match the followings are easy, where we solved, if I'll see from the starting, there are things which we have tried to solve, where we have taken adiabatic system, delta T, where we have used the concept of entropy generation. So this was an important thing which we would need to remember. Then there heat absorption. So there are like things which has been given extra. There are things given extra because you need only two, or you only need QH and WN. So Wn and QH are already given, so this is the formula which we need. Okay, so three things. This is a good question where the description where it is saying heat engine 1, T mid, heat engine 2 and TL value has been given to you. Now on that mercury question, which is also similar to your question number 9, so it is given that delta T value, it has already been given alpha at 0, 2, and here you have just taken 2 or 3 values like product rule you have applied, the formulas are LP, KT value, and you have, when you'll integrate it, you'll understand then what are the values. And for a gas, behavior can be described by, so you just have to use Maxwell relationship. So just remember the Maxwell relationship and you'll get to know, and basic differentiation, basic partial derivation. Which we have to do here. Then we went to a very good question, so I'll just start like this, because you should always remember that Cp minus Cv is equals to R, but people generally don't know how these values come from. So when you solve this and you keep things constant, it's a good question which people should remember also. It comes in GATE, it comes in things test. This is a basic multiplication. This is like basic question which we apply. Okay, question number 8, mu I, the chemical potential of species I, can be expressed as. So for the first law, you need to remember like what is the value, and you should remember what all the things are keeping fixed. So you should remember that you have keep these things fixed, so you'll get these values. Okay, and the COP of refrigerants, the eta value, Carnot engine in any refrigeration. So remember that second law is there, and you are good to go. So I hope you got whatever you wanted to. If any questions, you can comment me out, like whatever problems you have taken. I have covered almost all the questions of assignment 2. If you have any queries, if you have any problem in anything, I have almost covered every question, every query of it. If you have any doubts, please upload on, please put it as a comment or put the questions in the question box, where TAs either can reply to you or we can also reply at the same time. Okay, and I will also upload these videos. I will also upload my lecture notes, which you can see, which you can think about where it is wrong, where it is right. If there are problems, I'm not saying that I have exactly done everything well, but to my knowledge, utmost knowledge, these values are correct. And wherever there is issue, I can solve it. Rest here are the notes which I will upload, and you will get to know everything. Okay, I hope there's no problem now, and you can go ahead with anything. Thank you so much. I'll wait for 2 minutes if somebody has some doubt, and if not, we will conclude this meeting. Thank you so much, everyone. I am stopping this video, and thank you so much.